All right, welcome to part 2 video for unit 3. We're going to talk about angles and parallel lines and how if you have two lines that are intersected by a transversal and those two lines happen to be parallel, what happens? So the first thing is that there is a postulate involved with two parallel lines that are cut by a transversal, and that means that corresponding angles are congruent. Remember, postulate is something that we just assume to be true. So if two parallel lines are cut by a transversal, the corresponding angles are congruent. That is the corresponding angles postulate. So what that means is if angle 11 here is 51 degrees, and notice it says line X is parallel to Y because of the markings here. So we know X is parallel to Y. So what that means is if angle 11 is 51, then what about 15? Well, we know 15 and 11 are corresponding. So therefore 15 is also 51 degrees. Now, what about 16? Well, what type of angles are 15 and 16? And if you said vertical angles, you would be correct. And what do we know about vertical angles? We know that vertical angles are congruent, which means angle 16 is also 51. And notice 11 and 16 are the same. And what type of angles are 11 and 16? 11 and 16 are alternate exterior angles, which is going to lead us to one of our theorems that we just proved, that alternate exterior angles are congruent. So let's look at number 9. So why don't you try number 9 on your own, and then we'll go over the answers. All right, so for number 9, 18 is 42, so that means 22 is 42 because they're corresponding. And then 22 and 25 are vertical, so therefore 25 is also 42. So that leads us to a couple of different things. So first of all, if you notice here in this picture, if 18 is 42, 21 is also 42. So notice that 21 and 22 are equal. And what type of angles are 21 and 22? They are alternate interior angles. So therefore, one theorem is that alternate interior angles are congruent by the alternate interior angles theorem. Now, something also to keep in mind is if this is 42, 18 and 20 are supplementary because they're a linear pair. So 180 minus 42 would give you 138. So notice that 20 and 22 are supplementary as well. So therefore, consecutive interior angles are supplementary. So that is the consecutive interior angles theorem that says that consecutive interior angles of parallel lines are supplementary. And then the last theorem here is what we proved before. We said the alternate exterior angles theorem is if two lines are parallel, then alternate interior angles are congruent. So here's the wording that we're going to use. Parallel lines imply corresponding angles congruent. Parallel lines imply same side or consecutive interior angles supplementary. Parallel lines imply alternate interior angles are congruent. Parallel lines imply alternate exterior angles are congruent. So the only ones that are supplementary are the consecutive interior. Everything else is congruent. Alternate interior, alternate exterior, and corresponding. So then if you look at number 10, it says, so notice you have some parallel lines, and it says given measure angle 5 is 2x minus 10, and angle 7 is x plus 15. Find x and the measure of all numbered angles. Well, 5 and 7 are corresponding angles, so I know they're equal, right? So I know 2x minus 10 is equal to x plus 15. Since they're corresponding angles, that means corresponding angles are congruent. So I subtract x, I add 10, so x equals 25. So that's the first part. And then to find all the measure of all the numbered angles, well, angle 5 is 2 times 5 minus 10. So it's, or sorry, 2 times 25 minus 10. So it's 50 minus 10, which is 40. So if angle 5 is 40, angle 7 is 40. And then what do we know about 5 and 6? Well, 4 and 5, excuse me. 4 and 5 are alternate exterior. So that means 4 is 40. So if we make a little chart here, measure of angle 4 is 40 degrees. Measure of angle 5 is 40 degrees. Measure of angle 6, well, 6 is a linear pair with 4, so it's 140, it's supplementary. And 6 and 8 are corresponding, which means that they're the same. But first we'll say the measure of angle 7, which is 40. And then the measure of angle 8, which is 140. So there are all the angle measures. All right, so next it says given the measure of angle 4 is 4 times y minus 25. So let's erase this stuff because we're going to have to use the same picture. And angle 8 is 4y. So measure of angle 4, if I distribute this, it gives me 4y minus 100. And angle 8 is 4y. Well, we know 8 and 6 are corresponding, so 6 is also 4y. And we know 4 and 6 are a linear pair, so therefore 4y minus 100 plus 4y is equal to 180. 4y plus 4y is 8y minus 100. You add 100 to both sides. And divide by 8. So y is equal to 35. So then to find the measure of all the angles, well, the measure of angle 4 is equal to 4 times 35 minus 100, which is equal to 40. The measure of angle 5, well, notice it's alternate exterior angles, so 4 and 5 are the same, so it's also 40. The measure of angle 6, if this is 40, then it's going to be 140. The measure of angle 7, because 5 and 7 are the same, so it's also 40. And the measure of angle 8 is 140, because you put the 35 in. All right, go ahead and try number 12 on your own. Actually 12 and 13 on your own, and then we'll go over the answers. All right, so here, go ahead and check your answers. The first one, because 1 and 2 are alternate exterior angles, you can set 9x plus 6 equal to 10x minus 6. You get x equals 12, and then you substitute 12 in for angle 1, so 9 times 12 plus 6 is 114. And then that means 2 is 114, and 2 and 3 are corresponding, so that means 3 is 114 as well. For the next one, it tells you angle 2 is 145, so that means 1 is supplementary because it's a linear pair, that's 35. And then 3 and 1 are corresponding, so that's 35. But then 4 and 3 are a linear pair, and so you can just do linear pairs and corresponding all the way through to get all your answers. They're all either 145 or 35. All right, and then the next one, in the map shown, 5th Street and 7th Street are parallel. So these two are parallel right here. At what acute angle do Straight Street and Oak Avenue meet? So here's Straight Street and here's Oak Avenue right here. So it wants to know what is the angle there that they meet at. So we'll call this x. So we know that 75 plus this whole thing, 75 degrees plus x plus 53, is equal to 180 degrees because they're corresponding, or there's consecutive interior. Because notice this angle here and this whole angle here are consecutive interior angles. Because notice here's the transversal, and then you have the two lines going this way, so those two are consecutive interior. So 75 plus 53 is 128. And then you subtract 128. So you get x equals 52 degrees. That is the acute angle at where they meet. So the next theorem, the perpendicular transversal theorem, is if a transversal is perpendicular to one line, then it must be also perpendicular to the other parallel line. All right, so if a transversal is perpendicular to one of two parallel lines, it also must be perpendicular to the other one, because notice these would be corresponding angles, so they have to be congruent. All right, so once again, if a line is perpendicular to one of two parallel lines, it's perpendicular to the other. All right, so that concludes our video for part 2, and next time we'll talk about slope. Have a good evening.